Alright, so we studied the idea of gravitational potential energy in the last video. Now there are a couple of ideas left, so let me just talk about those. So do you guys remember how we did the rate questions related to work? Similarly, you may also be asked for the rate of gravitational potential energy. So a question like, at what rate is the gravitational potential energy increasing? So we know that gravitational potential energy delta EP is mg delta H. So if we're talking about the rate of increase of this, there's just an additional time here. Now this idea can be assessed in one of two ways. One way is this, that it might be at for something raised at a velocity. So raised at some constant velocity. Now in such cases, what you have to think about is that the question would be something like this, that it would give you the mass, the gravitational acceleration, and the velocity of something, and you would be asked to find the rate of increase of gravitational potential energy. In such questions, what you have to remember is that delta H over delta T, this can basically act as your velocity. So in that case, the rate of increase of potential energy would become mgv, right? So delta H over delta T basically became V. What's the other possibility? Another possibility is this, where it talks about some mass, or let's say, so rate of mass here. So in this case, it would again give you G. It would give you the height that it goes through, but it would also say something like this, that some mass is raised at a rate of, let's say, 5 kg per second. In that case, it gives you m over t, which you know is the mass flow rate, which is m dot, g is g, and delta h. So that is, in that case, the rate of change of potential energy. Again, this, in a way, if you think about it, this is also just power, but we need to be comfortable with the terms that are used. Also, a disclaimer here, these are not formulas which are meant to be memorized. Also, we cannot do all of these type of questions right now because we haven't officially gone on to power, but this is just showing you that these are some different possibilities which the examiner can ask in these different questions. Now what we'll be doing in this video is we'll be going on to different past paper questions of different types, just to have a feel for how the examiner can assess these concepts. Because again, we have not done the chapter in its entirety, we can't really move on to structured questions. So we'll start by looking at some MCQs. Okay, let's look at this one. An object of mass m is dropped onto the surface of two planets X and Y, which have no atmosphere, so no air resistance. Height from which the planet is dropped and the change in GPE of the object for each planet are given in the table. So for planet X, it says that the height that it's dropped from is 3, the change in GPE is delta E. Acceleration of free fall near the surface of planet X is gx. What is the acceleration of free fall near the surface of planet Y? Alright, now what do we think about here? So we can see that both of these are the same mass on different planets, right? So we are asked for the acceleration of free fall on planet Y in terms of whatever the acceleration of free fall on X is, which is called as gx. So I know that if it's the same object, so basically mass is the same, right? So what I can do here is that delta EP equals mgh. M is the same in both cases, so m gx, and this is 3. What this enables me to do is get an expression in terms of m. So I can say m is delta E over 3gx, right? Now in the second part, where it says that for planet Y, the change in GP is 4 delta E. So I know that m is the same. So it's m gy into 4 in this case, and I can just plug in the expression from the previous part for m. So then this expression would become 4 delta E equals delta E over 3 gx into gy into 4. Now what you'll see happening here is that the delta E's cancel out, the 4's cancel out, and you basically needed gy. So if you make gy the subject, that turns out to be 3gx, which is option C. So I feel like a lot of people have problems with this, even though this wasn't very difficult. You just need to write down the expression, try to think about what can happen, and just go ahead and solve this. All right, so the key is to not get fazed by symbolic questions. Let's look at this sort of a question. Kind of similar to what we just wrote down above in the lecture. A man has a mass of 80 kg. He ties himself to one end of a rope which passes over a single fixed pulley. He pulls on the other end of the rope to lift himself up at an average speed of this much. What is the average useful power at which he is working? Alright, so in this case, I know that if he's lifting himself up, that's basically potential energy which is increasing. But it's asking about power, which is really just the rate of change of potential energy. Now I am used to seeing this as mgh over t, but there's no h. Instead I have the velocity, which I can think of as this being h over t. 50 centimeters per second, which is 0.5 meters per second. Mass is 80, small g is 9.81, and this is 0.5. So 40 into 80 into 0.5 is 40, and 40 into 9.81 is approximately 400 watts, and 400 watts can be written as 0.4 kilowatts. So that's B. The reason I'm doing this this way is because I don't have a calculator with me right now. Another one, on the surface of a planet, 30 joules of work is done against gravity to make a mass of 1 kg, to raise a mass of 1 kg through a height of 10 meters. How much work must be done to raise a mass of 4 kg through a height of 5 meters on this planet? Okay, so in this case as well, you can see that basically mass is the same, right? No, mass is not the same, my bad. Mass is not the same, but you're on the same planet, so G is constant in this case. So it's different from this one. Again, what you can do is first you might use the GPE formula. You have E, you have M, you have H, and you can find G. And then once you find G, you can plug that in here and find the new energy. Or there's also a smarter way to do things. Since delta EP equals mg delta H, and the only thing which is constant here is delta is what do you call it, G. So I can also say delta EP is proportional to mh. So it's proportional to both m and to h as well. Now, what was my old potential energy? That was 30, right? So that's 30 joules, which is also the energy. And now I can think about how mass affects the potential energy, how height affects the potential energy. So I can say that because the mass became 4 times its value, because of direct proportion, potential energy would also become 4 times its value. And because height was previously 10, now it's 5, it has halved. So potential energy would also halve because of direct proportion. The answer to this is 60. This is just a smarter way to do this. And if you think about it, I could have also done this here. But in this case, it would have become a bit messy because this is all symbolic, right? So yeah, that's the idea here. Okay, this is another common type of question. So this question, a uniform solid block has weight 500 Newton, this width, this height. The block rests on the edge of a step of depth 0.8 meters as shown. The block is knocked over the edge of the step and rotates to 90 degrees before coming to rest with the 0.6 meter edge horizontal. So it didn't just move down, it toppled over. What is the change in GPE of the block? Now, in a case like this is also not very difficult. If you reread the question, you'll see the examiner has dropped a hint for you. Because this is a uniform block, you know that its weight is going to act from the center. So you can take the center as your reference, right? So you know the weight, all you need is the change in height, which is going to be this. Now, because this is uniform, this small length is going to be half of 0.4, which is 0.2, and this is 0.2. This small distance is half of 0.6 from here, which is 0.3, and then I really just need this distance. So all of this is 0.8, this is 0.4, so this is also 0.4, right? So this height which I need then is 0.3 plus 0.4 plus 0.2, which is 0.9, right? So EP is mgh. Mg is 500, that's a weight, and h is 0.9. So this turns out to be option C, which is 450. Let's move on to the next question. Pretty easy. A weight W hangs from a trolley that runs along a rail. The trolley moves horizontally through a distance p and simultaneously raises the weight through a height q. As a result, the weight moves through a distance r from x to y. It starts and finishes at rest. How much work is done on the weight during the process? So if it starts and finishes at rest, this is meant to show you that the work being done, none of it goes into kinetic, so basically all goes into potential. So you know that the weight would be marked downwards like this. And if we are talking about work, so I know that the weight is vertical, so the distance must also be vertical, which is WQ. That's the work done. One of the few last questions left. A ball of mass m is thrown up to a height h in air with an initial velocity v. Air resistance is negligible. Acceleration of free fall is g. What is the total work done by the gravitational force on the ball during its flight from P to Q? So I know that the work done is W, the weight is acting downwards here. From here to here, I would say that work is done against the weight. And you can also see that makes sense because it's gaining GPE. And from here to here, work is done by the weight because it's losing GPE. So an equal amount of work done against the weight here is also done by the weight. So overall, there's no work done, which is 0. A easier way to talk about this is to just say that there's no overall vertical displacement. So there's no work done overall. Last question. Pretty basic question, honestly. Initially, 4 identical uniform blocks, each of mass m, thickness h, are spread on a table. How much work is done on the blocks in stacking them on top of one another? So this is going to be in its place. This one is stacked on top. So this goes through a height h. So mgh is the work done here. In this case, this would have to go with this here. This would have to go through a height 2h. So potential energy becomes 2 mgh. Similarly, the third one, 3 mgh. So 3 plus 2 plus 1, that's 6. So this one had some questions related to GPE. In the next video, we will be moving on to kinetic energy and how that formula works and how questions related to that idea is asked. So I'll see you in the next video now. Bye.